Hi everyone, I'm Whit Roy. Today we're going to do a combination DC circuit calculation, focusing on understanding how to find the total resistance, total current, and the individual voltage drops, currents, and power dissipation across each resistor. Let's break down each step carefully to grasp these essential concepts. Let's look at the question first. This circuit includes a series resistor R1, which is followed by two parallel sections. The first parallel section consists of resistors R2 and R3, while the second parallel section contains resistors R4, R5, and R6. The circuit is powered by a 24 volts DC supply. Let's work out the total resistance, total current, and each resistor's voltage drop, current, and power dissipation. Before we dive into the calculations, let's start with some key guidelines. Step 1. Labeling all components clearly. It's vital to label every component in your circuit. These labels help us apply formulas correctly and avoid common mistakes. Step 2. Applying Ohm's law correctly. Remember, Ohm's law should only be applied to components with the same label. This ensures that we're using the correct values in our calculations. First, redraw the circuit diagram to make the question easier to solve and label it clearly. Label the voltage and current for each resistor as well as the total voltage and total current. We can think of the equivalent parallel resistance R23 as a single, larger resistor that combines the effects of R2 and R3 in parallel. Similarly, R456 represents the combined effect of R4, R5, and R6 in parallel. By grouping them as R23 and R456, we simplify the circuit, making it easier to calculate the total resistance and current. After proper labeling, we can easily identify some key relationships. I total equal I equals I23 equals I456. I23 equals I2 plus I3. I456 equals I4 plus I5 plus I6. V total equals V1 plus V23 plus V456. V23 equals V2 equals V3, and V456 equals V4 equals V5 equals V6. These relationships become clearer once the diagram is properly labeled, so ensure that all components are labeled accurately to avoid confusion. Step 1. Calculate total resistance. For combination circuits, start by calculating the equivalent resistance of parallel sections. For instance, if R2 and R3 are in parallel, calculate their equivalent resistance as R23 equal 3.75 ohms. Similarly, calculate R456 equals 4.8 ohms for R4, R5, and R6. Then treat R23 and R456 as two resistors in series with R1. The total resistance is found by adding R1, R23, and R456. Thus, R total equals 13.55 ohms. Step 2. Determine total current. Once we know the total resistance, we can find the total current using Ohm's law. I total equals V total divided by R total. This gives us the current flowing through the entire circuit. I total equals 1.77 amperes. Step 3. Find voltage drops. For V1 calculation, we can use Ohm's law directly. Given I1 equals I total equals 1.77 amperes and R1 equals 5 ohms, the V1 equals I1 times R1 equals 8.85 volts. Then we can work out the voltage across the parallel section, which we label as V23 and V456. We apply the Ohm's law. V23 equals I23 times R23, and we know the I23 equals I total equals 1.77 amperes and R23 equals 3.75 ohms, so V23 equals 6.64 volts. Similar, we can get V456 equals 8.5 volts. From those relationships we get before, we know V2 equals V3 equals V23 equals 6.64 volts, and V4 equals V5 equals V6 equals V456 equals 8.5 volts. Step 4. Find currents. As we already know each individual resistor's resistance and voltage drop, so we can use Ohm's law directly to get each individual current. I1 equals V1 divided by R1 equals 1.77 amperes. I2 equals V2 divided by R2 equals 0.664 amperes. I3 equals V3 divided by R3 equals 1.107 amperes. I4 equals V4 divided by R4 equals 1.0625 amperes. I5 equals V5 divided by R5 equals 0.425 amperes. And I6 equals V6 divided by R6 equals 0.283 amperes. Step 5. Calculate power dissipation. Now, to find the power dissipated by each component, we can use any of the following formulas: P equals V times I, or P equals I squared times R, or P equals V squared divided by R. For this question, we choose to use P equals V times I, as we already know each component's voltage drop and current. So we can easily work out P1 equals V1 times I1 equals 15.65 watts, P2 equals V2 times I2 equals 4.41 watts, P3 equals V3 times I3 equals 7.35 watts, P4 equals V4 times I4 equals 9.03 watts, P5 equals V5 times I5 equals 3.61 watts, and P6 equals V6 times I6 equals 2.41 watts. Step 6. Calculate the total power. When it comes to the total power, we have two calculation methods. Option 1, we can calculate the total power dissipation for the entire circuit using any two of I total, V total, or R total. Option 2, we add up the power dissipated by each individual component, P1, P2, P3, P4, P5, and P6. P total equals 42.48 watts. Summary. Key points to remember are: draw and label your circuit properly. Consistently apply Ohm's law to the same labeled parts. Thank you for watching.